Hi, today we're going to work on perfect complements utility functions. And so to start off, complements are goods that go together. So think of it as like salt and pepper, right and left shoe. I really like the right and left shoe concept. And so you're probably asking like, okay, why does the utility function look like that? Why is there a min in front of it? So let's take the right and left shoe concept. So let's say you have two right shoes, but three left shoes. If you have two legs, what are you going to do with the third left shoe? Do you care about the third left shoe? No, you're going to end up choosing the two right shoe and two left shoe, right? So what I did was, okay, I had 2 and 3, but I chose the minimum one. And that's why you have your minimum. You can think of it as a different example too, like 4 and 5. That fifth one's kind of useless. We end up choosing 4, right? So the question asks that, okay, Bob's income is $8 while the price of X is $2 and the price of Y is $1. So right when you see like the price of X and his income, you have to start writing your budget constraint. And so just write down your budget constraint, right? I have my 2, so that's going to be my coefficient in front of my X. Okay, that's my coefficient in front of Y, right? So this is going to be my expenditure on good X, expenditure on good Y is equal to 8 because that is the highest income that I have. That's my budget constraint. Now, you're probably asking, wait, I can't really find the fraction. I can't really do like the utility function here. It's weird. I can't just do 2 over 3. Like, that just sounds weird. So for utility functions, for perfect complements, what you do is you see that comma, right? You take that comma and you turn it into an equal sign. I can't really write it here, but just turn it into an equal sign, right? We want the 2 over here, the 2 kind of separations, those two to be equal, right? Like my left and right shoe example, I said I had 2 here, 3 here, but we're going to end up choosing 2 and 2. 2 right shoes, 2 left shoes. Perfect. So we want them to be equal. That's why I kind of equate the 2x and the 3y. That is how you find your utility function, right? I have 2x equals 3y, solve for x or solve for y, it doesn't really matter. I kind of prefer to do that solving for y because I can just say like, okay, I can just plug this y into my budget constraint and not have to like do 2 times blah, blah, blah. So here's my y, right? Here's my y. And what do we normally do, right? For utility functions, we always kind of plug back into our constraint that we have. Our constraint is our income. We're always constrained by the income that we have. So we can't always reach our maximum utility because we're always constrained by the money that we have. Plug this back into my budget constraint, right? And that's where I get the 2x plus this, because that's my y, is equal to 8. Now we solve for x, right? That's pretty easy. You just add them up. Put the 3 times 8, 24. 8x is equal to 24. And you get x is 3. And then what you can do, you can just plug that x back in here, right? Or you can just plug it back in here. There are lots of different ways places that you can plug it back in. You can also plug that x back in right over here too, right? You can do x, you can do x is 3, 3 times 2 is 6, minus 8 is going to give you 2. That's how you get your optimal bundle, 3 of 2. One way to check your answer, plug that 3, 2 back into our utility function, right? Back into our utility function, we get min of 6 and 6, 6, 6. What is the minimum of 6 and 6? It's just 6. And this optimal bundle is your answer. One question that is always asked on exams or something that might be asked is, okay, is this a complement or a substitute? And we just talked about this, right? It's a complement, and one way to know that it's a complement is by seeing that if you increase the price of one good, if you increase the price of the left shoe, consumers would not want to buy both of them, right? Because they go hand in hand, they go together. So increasing the price of one would decrease the consumption of both of the goods, both X and Y, not just one, because they go together. So on to the second problem. I really like this problem because this is something that might pop up on the exam. and it kind of uses all the things that we've learned about complements, utilities. Okay, so it says Bob always consumes exactly A units of X with every B units of Y. For part A, find Bob's utility function. This is going to be worth a lot of points because lots of students make a mistake on that by doing the exact opposite of what's the right answer. Normally, students would do like, oh, okay, A units of X, B units of Y. So it's going to be AX comma BY. No, it's not. If you kind of draw a graph, if you draw a little graph, you can compare the two units. You can just like put in like a 4 and 8 or 2 and 4 and see that it would be flipped. Okay, it would always be flipped. So it would be A units. So it would be like BX comma AY. Just know that. Put in your put it in your notes. It will always be flipped, and we can kind of work through these problems and know why it's going to be that way. Also, side note, here is the formula. Here's like the trick, like to get your optimal bundle like in a quicker manner. But I think I would suggest that you like work through the problems on an exam actually, and not like just use the trick. But on a multiple choice, that's very helpful. So yeah, so this is our utility function. It's going to be worth a lot of points. Okay. Part B says, okay, what if you optimize by choosing the bundle 8 comma 4, right? So one thing that you would do is, okay, let's say that we had, I like to look at this, right, 8 and 4 and see the relationship between 8 and 4, right? 8 is 2 times 4, right? 8 is 2 times 4, meaning that this is my x, right? This is my y. So another way of writing that is x is equal to 2 times y. If that doesn't make sense, just plug this back in, right? This is my 4 is my y, right? Plug back 4 over here and you get x is equal to 8. Perfect. This equation makes sense. That's my trick of showing that. Okay, now look at the coefficients in front of x and y. In front of this is just a 1. In front of this is a 2. This is my b. This is my a, right? They're both the same thing, right? This is my 1. This is my 2. B is 1. A is 2. 2 is bigger than 1, so alpha is greater than beta. That is how I got that. Okay? Now you're probably asking, why is there an equal sign? Remember what we talked about. If there's a comma here, we just kind of equal them together because we want them to go together. Okay. Same thing with C. If you know that A alpha is greater than beta and you see that these numbers are flipped, you probably know that alpha is less than beta here. But let's work through it, right? Here is our 4. Plug this back in here and you get 8 is equal to 8. Perfect. So my equation works. Now I'm just going to look at the coefficient in front. Okay, here is a 2. Coefficient in front of y is just 1. Oh, great. My beta, is greater than my alpha, right? Because this is 2, this is 1. Perfect. Alpha is less than beta. And here, this is really easy because I see that, okay, they're together. They're equal, right? 8 and 8. Left and right shoes, they're both 8. Perfect. We want them to be equal. 1 in front here, 1 in front here. Alpha is equal to beta. The coefficients are equal to each other. Part E says, suppose that the price of good Y rises, what happens to Bob's demand for X? This is probably a trick question. Just remember that they're going hand in hand, right? X and Y go together. If the price of good Y is rising, then the demand for good X should be decreasing as well, right? Because the demand of good Y also decreases. That's just a normal basic econ concept, right? Because they're complements, both good X and good Y demand will decrease since the price is rising. Now here, the other question is, if income rises, right? What happens to Bob's demand? If income is rising, I have more money in my pocket, right? That means I can just buy more goods. I can buy more things. Now, if X and Y go together, that means I'm going to buy both X and Y together, and it will both increase. So the demand for Y will increase. Okay, well, demand for Y increases, but just know that demand for X also will increase because they go hand in hand. So, yeah, thank you.